Okay, so we're just going to pick up where we left off here yesterday. And I kind of stopped here because this next piece is a little bit different as far as like how it's written and maybe what it's asking you to find. It's different than what we were doing yesterday. Yesterday we were just working with either an explicit formula or a recursive formula. We were trying to find the next so many terms in a sequence. This next piece is called summation notation, and it has that word sum in it. And when you think about sum in math, that means that you're adding up. So instead of just finding the terms, we would then be adding all the terms in the sequence too. This notation is a little different than what we've seen before. It's got kind of this weird looking, almost like an E symbol. It's a Greek letter. Okay, math people love the Greek alphabet. So that's another Greek letter that they use to kind of represent sum. And in that, you're going to have a piece on the bottom and you're going to have a piece above it. The piece on the bottom where it says like I equals 1, it doesn't have to say I, it could say n equals or x equals, but that is just talking about the index, which is just the number you're going to start at for your summation series. So if it was like a 3 down there, then I would start by putting in a 3 to my rule and then add it up to wherever it ends. Now at the top where it says n up here, that's going to get filled in with a number like a 7, a 5, 10, and that's just going to say we want you to start at the bottom number and we want you to keep going until you get to the top number. So you're not going to be performing an infinite series here. It's going to have to say you start here, you end here, you figure out what those terms are, and then you would add them together to do the sum. So it's kind of what this is showing you here. It's got limits, an upper limit and a top limit there, lower limit and an upper limit there to kind of tell you where you start and stop. And it always increments by 1, which means if the top number was a 10 and the bottom number was a 5, you would go 5, 6, 7, 8, 9, 10. You would not skip and just do like 5, 7, 9 and then do 10, or just pick and choose whatever you want. You would just go in order one at a time and do them. So for example, we've got this one. The summation here says that you start at 3 and you're going to go up to a 7. That's all based off of the number on the bottom and the number on the top. That tells you where you kind of fill in. And they have a chart for us here. So the index starts at 3, goes up by 1, so 3, 4. Next one would be 5, 6, and then 7. And the rule follows that sum symbol. So it says n factorial plus 2 times n. We saw factorials yesterday. We're just plugging in our numbers now for n. We're going to use the factorial, which you can manually multiply that. Or I think I mentioned yesterday that the calculators that I have in here underneath the PRB button, that's the probability button, that it does have a exclamation point in there that you can use, and it'll start calculating those factorials for you. But so they did the first two for us. 3 factorial plus 2 times 3 is 12. 4 factorial plus 2 times 4 is 32. So we would keep going. Next one would be 5 factorial plus 2 times 5. Then 6 factorial plus 2 times 6. And then 7 factorial is our last one, plus 2 times 7. So then we would just start like multiplying and adding here. So I would probably get used to using your exclamation point. It's going to make this a little bit easier. So if I were you and I had a calculator, I would just type in 5 factorial, 5 with the exclamation point, and then you can either mentally multiply there or you can type that in too. Okay, as I go, the numbers that I got here were 130, and then the next one was 732. And then the last one was 5,054. You can see they're getting really big fast because you're increasing the factorial. So it's just going to increase the multiplication that's happening there. So they start to get really large. Now that we stop here, and then what I would do to actually find the sum is I would be adding all of these numbers up together. So I would add them all, and that would give me my actual sum. Okay, now I don't know what that is. I didn't actually write that down. But if I were to add those up, it would get me some number down here, and that would be that sum of the entire series. So starting at 3 to 7, the sum of all those numbers would be whatever that is added together. If you want to add it together on your own, you can. I don't have it written down, so I don't know what it is. Okay, so that kind of gives you an idea of how this is going to work for the summation ones. Now on the next page, if you guys flip that over, there are some like special properties of sums, just some things to be aware of so that if you see a sum that's written a particular way, you have some things that you can do with it if you want to manipulate it, or if maybe, like I talked yesterday, sometimes when we plug certain things into our calculator, it like maxes out the capacity that the calculator has to actually work with those numbers. And so we can actually use some of these rules to break our sums apart and maybe make it a little bit more manageable for us to be working with in our calculator. The first property is just if you have a sum and the number that's sitting in front of it, so like this piece here, is just a constant, meaning there's no variable, there's no x or n or anywhere for me to actually plug in numbers. What that says is all I need to do is take the constant number sitting in front of that symbol times the upper limit of my sum and just multiply them together. So they give you an example over here. When the 7 is written here, there's no letter that follows the 7. It doesn't say 7n, it doesn't say 7x. I don't have anywhere for the numbers in my sum to even go. Like I don't have a place to put the 1, 2, 3, 4, and 5. So instead, you just take the upper limit, which is 5, and you multiply that times the 7. And so the answer for that one would just be 35. That only happens, though, if you have just a constant. Once you start having variables thrown in, then you'll actually have to work with it like we did on the last example. The next one, though, is if you have a constant that you could possibly factor out of the expression, or maybe it's written where there's like a number and then everything that follows it that has the variable is inside of parentheses. You can pull that out into the front and you can just work with the stuff inside the parentheses if that makes it maybe easier. And then at the very end, you'll multiply by that number that you wrote out in the front. So they're showing an example again over here. 4 is written in front of the parentheses 2 plus I. So what they did is they just put 4 out front. They moved it to before the summation notation. And then they would just work with the 2 plus 1. So they would, my upper limit is 3, my lower limit is a 1. So they would just put in 1, 2, 3. You'd add those numbers together and then you would end up multiplying it by 4. So instead of doing those every single time, you multiply by 4 and then adding. It's just a different way to approach that. And then the last one is if you have a sum and the quantities on the inside are separated by plus or minus signs, you can actually split them apart and evaluate their sums separately as well. So over here on the example, we start with 2i plus I factorial. What they're doing is because you're both using the same summation for both of those, they're splitting it apart. And so they're saying, instead, I'm just going to do 2i first. I'm going to focus on that sum series. And then I'm going to do I factorial. I'm going to focus on that series. And then I would end up adding the two answers together. You don't have to work with them this way. Sometimes it makes it maybe easier for us if we're calculating or if we're trying to do things mentally. We don't have access to a calculator and we're just trying to do these like more quickly. We can split them up and then maybe make the numbers a little bit easier for us to work with. So let's do some examples, kind of practicing with some of these. The first one is really no different than what was up on the chart. Okay, again, I notice that 7 is out front. There's no variable attached to it. The upper limit is still 5. So I just multiply 5 times 7, I get 35. So this would be your answer here. Okay, the next one, I'm kind of showing you how if I were to evaluate this sum as it's written, or if I were to split that 4 and pull it out to the front, that it's not going to change my answer at all. So how I would work with this if I didn't want to split it apart, I was just working with the rule as it says and the summation that I have here. I would start, my lower limit is a 2. So I'm going to start by putting a 2 in for the I. So it would be 4 times 2 plus 2. I would do all of that for my first term. Okay, but then we're going to keep going in my limit. So I got to go all the way up to 4. So I got to do this a couple more times. But then you're going to be adding all of these numbers together at the end. So I'm going to put a plus sign here. And then the next one would look pretty similar, except instead of saying 2 plus 2, it's now going to say 2 plus 3 because we're going up a step on our sum. And then the last one Again, very similar. 4 times 2 now plus 4 for my sum. Okay, so let's work with this here. What would be the answer to this first one? If I just focus on that piece on the inside there. 2 plus 2, and then times 4 would be what? 16. 2 plus 3 times 4? 20, and then the last one is 24. So if we add those together, we get 60. So that would be the final answer because you're adding up all the terms within your sum series. Now they're showing you the same thing down below, okay, but what they did is they separated it out. So instead of working with the rule, they put the 4 here and they wrote that out front, so they're going to deal with that at the very end. So instead, they work with this rule just 2 plus I, and they plug in a 2, a 3, and a 4 for I. So now you're just adding. 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4 is 6. So we add just this rule column, and we get 15. But because we took that 4 out, we have to multiply the 15 by 4. So that's what they're showing you down here. And we still get 60. Same answer, just 2 different ways with approaching it. Does that make sense? Okay, so you don't have to separate it, but if these numbers started to get really big and maybe your calculator is throwing a little bit of a fit and it won't do it for you, then maybe try to split it up and see if that helps it a little bit. Okay, so let's go on to the next example here. This one's showing you the case where I've got 2 pieces in my kind of rule here. I'm going to separate them. I'm going to do one where they're all together, and then we'll do one where they separate them so you can see how you're still going to get the same answer. What's the lower limit for this one? Like, what number do we start plugging in first? 1, and then we go up to 4. So I need to plug in a 1, a 2, a 3, and a 4. So I got to do this 4 times. So I'm going to start out with the 1. So it's going to say 2 times 1 plus 1 factorial. We're going to do all of that first. And let's just do these as we go. What would this equal? 2 times 1 plus 1 factorial. 3. Okay, I'm going to go on to the next one now. So plus, now it would be 2 times 2 plus 2 factorial. What would that come out to be? 6. Good, 6. Next one. Now it would be 2 times 3 plus 3 factorial, which is good, 12. And then the last one we need to do for this series, because it ends at 4, is to plug in a 4. So 2 times 4 plus 4 factorial would be 32. And so the last thing I need to do, especially with those numbers across the top there that I wrote in blue, I just have to add them. So 3 plus 6 plus 12 plus 32 is how much? Good, 53. So there's my answer. So the sum of that series, going from 1 to 4, would be 53. Now, underneath it, they're showing you the same rule, but they are showing how if you split it apart. So if you just did the 2 times I piece, and you kind of worked with that, so you took 2 times 1 times 2 times 3 times 4, you get all of these numbers here. You add those together, and you get this 20 down below. Then you do just the I factorial. So 1 factorial, 2 factorial, 3 factorial, 4 factorial. You get all of these numbers here. Oh, that should be a 24. It looks like it kind of smushed that table together there. And then you add them together and you get 33. If you add 20 plus 33, you still get 53. So again, same answer, just a different way of working with that because you can split it apart. So it's up to you as far as when you want to maybe use those properties. If you like to think about splitting it into maybe smaller pieces for you to work with, that's fine. If you are comfortable with working with the entire rule, that is fine as well. So at the bottom here are 3 examples, just like the ones that we just talked about. You can decide how you want to handle them. I'm going to give you a couple minutes. Go ahead and try to do both of those there, and then I will maybe give you like 3 minutes here, and then I'll come in and I'll go over what I would have done. Okay, for the first one, because it's just a constant, you can just take 7 times 9. And you should have gotten just 63 for that one. For the next one, because there's a 3 in front of the parentheses, I kind of thought about like splitting it apart. I didn't use a table though to help me do this one. I just knew if I focus on the I plus 5 and I figured out what all of those were for my sum, that eventually I'd have to multiply it by 3. So I wrote it like this, 3 and then times, and then I kind of focused on if I started plugging in a 1, a 2, a 3, and a 4 here. So I did 1 plus 5, 2 plus 5. And again, I'm adding these all together because that's what a sum notation is telling me to do. 3 plus 5 and then 4 plus 5. This is really easy for me to work with more mentally. This is a 6, this is a 7, 8, and then 9. So I can add those and then take that times my 3, and I end up getting 90 for my final answer there. And then the last one, you can either do it in one swoop or you can split it apart if you want. I'm just going to do it in one, like I'm not going to split it, but you can if you need to. So I'm going to do 3 times 3 plus 3 factorial. That's my first term. And then plus 3 times 4 plus 4 factorial. And then the last one for this series is a 5. Like so. This ended up, this first one here would have been 9 plus 3 factorial. That ends up being a 15. This next piece ended up coming out to be 36. And this last one was 135. And then I add those together. And so I got a final answer of 186. Did anyone get all 3 of those? Yes or no? Okay.
Yes.
Yeah? Okay. All right, so that's it. You should have your homework already because I handed it out to you guys yesterday. So now you should be able to finish it. If you got to those problems at the very end that dealt with this notation, you now should know how to kind of handle that. So you've got the rest of class to go ahead and work.